everybody. Today we are going to solve LeetCode 200, which is called number of islands. It's a medium hardness question. So given a 2D grid map of ones and zeros, note that these are characters, not numbers. Count the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay. Here's an example. It's a grid given as a vector of vectors and they are a vector of character. So here we see that these ones are all connected on this line here, and this one and this 2 by 2 place is also connected, so we have just one island here. In this example we have this island, this indices, this one and this one. So our answer is going to be 3. So how we are going to approach this question is a very well-known algorithm which is called BFS, or breadth first search, or traversal, we can say BFT. So we could also use DFS, which is just starts from a point and goes deeper and deeper in each step. One of them uses the data structure stack and also can be done with recursively, which is DFS. But we are going to use BFS because I think it's more convenient here to just make use of a queue. This can be done with a queue, this can be done with a stack. Maybe we will get into the details later, but yeah, that's the idea. We are just going to start from a point and we are just going to mark that point, and maybe we can do them just zeros so that we do not visit that point again. And we will just mark all of the connected elements here zeros. So when we come to another position like this one, let's start from I equals 0 and j equals 0, I and j being indexes. So this is going to become 0, and then during that BFS, all of these ones are going to be zeros because they are connected. After that, if we have just another one in an index of graph, this grid or we can call it graph, so at that point we will not we will make another BFS, and the number of BFSs, possible BFSs or searches on this grid, is going to be the answer. So let's get into the code and we will see the reasoning better. So let's just first check if this grid exists, okay, because sometimes they make those kind of edge cases. And let's make another one, grid 0, size is equal to 0, and obviously we do not have an island, so we will return 0. And let's define n, which is grid.size, or the number of rows, and we will do it here. And we have, of course, number of columns as an m. So let me write them as rows, and here columns. Okay. So what are we going to do is we are just going to start from, let's say I is equal to 0, I is smaller than n, and I plus plus, and another for loop just for the columns, j is smaller than m, and j plus plus. So what are we going to check here? We are going to check if this element, the grid ij, is not equal to 0. Because if it is equal to 0, we do not care to start there. We do not want to start like this position, from this position. We want to start from the positions that are ones. Because after we are done with an island, they will all become 0. So that we make sure of not visiting the same island twice. So, okay, we checked if this element is not 0, which makes it 1, obviously. So what we are going to do is we are just going to, let's count these things. Let's call them answer, and we are just going to increase answer here, okay? And then what we are going to do is we are just going to, let's just mark this point. Let's make it a 0, so that we will not visit this position ever again. So what we are going to do is, we know that we can start from this position. We are just going to apply a BFS. So for that we can use a queue of pairs. Why pairs? Because we have two indices in the graph, and we can traverse on the graph using these indices. So that's why I use a pair. And let's call that Q conveniently. And then let's push the first position, which is I and j, here. And while the Q is not empty, which means we still have some points that can be accessible from the starting point, what we are going to do is let's take them to another pair here, the top one, which is actually called front in the queues and top on the stacks. So let's call that F, or front if you want. So this is going to be the front element of the queue. And what we're going to do then is we are just going to pop this position because we do not need that position in the queue. So we popped it and we have an F here. What we're going to do is, for convenience again, let's make int u another variable, f dot first. We just make it easier here using these two different variables. We have f second as v. So what we are going to do is we are going to check if we have elements on our rights and on our top, on our left, and on our south or down. Okay, so let's start with right hand side. So if we are going to go to the right hand side, we will just increase our j index, right, or b index, which is like on columns, and this is on rows. Do not forget that. So let's check if v plus 1 is still smaller than m, and if that position, u v plus 1 is still like 1, right, so that we can go there. If we can go there, what we are going to do is we are just going to first mark that position. We could do it when we pop over here, but I think this is a little bit easier. Or you could just pop this position here, and you could just mark grid uv. It wouldn't change like anything. So grid u v plus 1 is now a position that is under check. So what we are going to do is we are just going to mark that position, and we are just going to push this position as a pair, okay, as a pair to our queue. And we are just going to repeat this thing. This is obviously going right hand side, and we are just going to repeat this thing for left, down, and top. Okay, so 1, 2, 3, and 4. So we are just going to change this. Let's make left one here. Let me make this left, and this is going to be -1. And we are just going to mark it, and we are just adding it to the queue. And let's make it, of course, this has to be greater than or equal to 0, because if it's getting smaller, it cannot be greater than m. So this condition is also important. So here what we're going to do is we can just check I plus 1, which is the next row. So if we are on the first row, we can go to second row if it's applicable. So this is going to be u plus 1. Sorry, I used I again. Plus 1. Maybe I should have used u and v here, but I and j over inside. Okay, so this is going to be u plus 1 v. I hope I do not make any mistakes here, because it could get harder to find those kind of mistakes. So u plus 1v, u plus 1v, u plus 1. Yeah. So this is going to be again greater than or equal to 0, and this is going to be u minus 1, because we can get under 0, and that would cause problems. So this is u minus v. This is also u minus v, and this is the last point, u minus v. Yeah. So we basically added all the possible positions to the queue, and we are just going to process them. And as they are all marked, when we go to a position which was previously 1, it would also become 0, so that we do not visit the same island again. So at the end, what we are going to do is, if this is the end of the for, yeah, we are just going to return answer, and I hope this will work. Let's see. So we have a problem here. Expression is not assignable. Yeah, obviously. Let's go there. And it should be a check, not an assignment. Okay, so let's run this. So it works on this example. Let's check all the examples, and then we will talk about time complexity. Yeah, it's pretty fast and it works. So let's talk about time and space complexity here. So what we have is a loop here, so it is at least O(n) times n. But what we do here, although we have a while loop inside, just because we mark all the positions that we go, like when we take this thing and start from this position, all these ones are going to be zeros. So when we check if that position is a zero or not, we do not get into the same position. So at most, we will make this BFS for the number of islands. And if all of these were ones, we will just run this BFS just once. So it doesn't take anything. It has just, we will just visit all the nodes on this graph or on this grid just once. So it will make like on average O(1) time. Or when we sum it up, this is a what can I say? This is approximate, expected, yeah. Expected O(1) at the result. So this part is O(n), this part is O(m), so the result will be, let me write it here, O(n) times m. This is our complexity, and it's obviously enough for us. So thank you very much for watching.